In this video, we're going to prove the Pythagorean identity. Let's go ahead and write down what the identity is. The identity is that if you take the sine of an angle and you square that, and you add it to the cosine of an angle squared, it's equal to 1. Let me just point this out because this is important. What that means, for example, is if you had, let's do this in a different color. Let's say you had the sine of square root of 30 degrees, and you added that to the cosine squared of 30 degrees. That should be equal to 1. So what we could do is we could check this on our calculator and verify that if you do take the sine of 30 and multiply it by the sine of 30, get a number out there, and then add that to, now I'm going to drop down a line here so that I've got room, the cosine of 30 times the cosine of 30. So you get another number here, so you've got one number here, you add those together, you'll get 1. So what's the proof look like? So in math, it's important that we actually prove that it works for all angles. So for example, this might work only for the 30-degree angle, but maybe it doesn't work for the 45 or the 60 or whatever else that you happen to be working with. So when we just say up here that the sine squared of an angle plus the cosine squared of an angle is equal to 1, we want to make sure that any angle, so for any angle, this works. So it's true. That's what we want to show. How do we do that? Well, I'm going to give you a proof that is a visual proof, and it's going to use the Pythagorean theorem. So here's what we have. The directions tell you to do this. They say create a right triangle using the terminal side of your angle in the x-axis. So we're going to place an arbitrary angle in standard position on the unit circle. So let's draw out our unit circle. So I'll put my coordinate system in there. There's my circle. Put an angle in there. So I need an angle in standard position. Okay. Now I want to use this angle, call this theta. I want to use this angle to verify this formula. Now how are we going to do that? Well, let's label a couple things. First, let's create a right triangle by taking this side right here, this terminal point. So I've got a point up here, and I'm dropping down to the positive x-axis. I'm creating a right triangle. Now, the ordered pair, the coordinate of this point is given by the following. Its x value is the cosine of theta, and its y value is the sine of theta. That's by definition. Okay. Which means that the x value should be this length down here. Let me grab a different color here, actually. So the cosine is going to be this over here. The y value is going to be this length right here. So this length of the triangle is sine theta. So whatever angle it is, if it's 30 degrees, then the sine of 30 degrees is that height. And this length right here is given by cosine theta. Now, it's a right triangle. So since it's a right triangle, we know that if we square the two smaller sides, so if I take the cosine, this length right here, square it, and I add that to this length over here squared, I get the hypotenuse squared. So let's do that in red. Now, what is the length of the hypotenuse? Well, the important part is that we drew this on the unit circle. So the hypotenuse length is 1. So it should be equal to 1 squared. If we do a little bit of rearranging with our terms, we end up with sine squared theta plus cosine squared theta is equal to 1 squared, which is 1. And that's the proof.